Hello, welcome to this new video. In this video we are going to discuss some additional information that will help us to understand Cayleys theorem well. When we define a mapping Tg from G to G, where G is a given group, as Tg of x equal to Gx. So this is the way we define the function Tg from G to the same group, Tg, where x is an arbitrary element of G, but G is a fixed element, and Tg, after fixing an element in G, we define the map using that element Tg by varying the element x in G. So Tg of x equal to Gx for all x in G. Tg permutes, we know that Tg then permutes the elements of G. You can see that this means that this function actually permutes the elements of G. When we apply this mapping on G, the elements of G are then are permuted. Its position changes, but there is no new element added to it, added to the group G, and no element is removed from it. For example, we consider U12, and this can be illustrated using this example. U12 contains the elements 1, 5, 7, and 11. These are the members of the numbers. These are the numbers of numbers which are the members of the set, the group U12. And here that group is taken as G. We know that 1 is the identity element in this group, and so T1, by fixing 1 first, then we define T1 equal to 1, 5, 7, 11. Then the results, that means 1 is sent to 1, 5 is sent to 5, because 1 acts as the T1 acts as the identity. So 7 is sent to 7, 7 to 7, 11 to 11, match. Next, when we define T5, we get that the matching or the relation of elements, one by one, taking elements of G to some elements of G, and this it goes as 1 to 5, 5 to 1, 7 to 11, and 11 to 7. Then when T7 is considered, we get that this matching is 1 to 7, 5 to 11, 7 to 1, and 11 to 5. Finally, T11 equal to 1, 11, 5, 7, 7, 5, and 11, 1. Now G bar, G bar can be taken as as you know, G bar equal to U12 bar. It's equal to T1, T2, set to T1, T2, T3, and T1, T5, T7, and T11. T1, T5, T7, and T11. Then T1 acts as the identity in this group. We define the operation. We can define the operation in G bar as Ti. Ti stands for these numbers, these subscripts. So Ti star Tj equal to T of I star j. So Ti star Tj equal to T of I star j, where I star j is the this star operation. This operation is the operation which is defined on the first group. But this is the operation that we are going to define in the second group G bar, and where I and j can take the values 1, 5, 7, 1, 5, 7, or 11, any one of the values. For example, T5 star T7 is equal to T of 5 into 7. 5 into 7 is the member of a G. 5 into 7. What is 5 into 7? 5 into 7 equal to 35, but 35 is not a member of G, but you know that there is a number corresponding to this 35, and that is the remainder. Which is obtained when 35, this actual answer is divided by 12, then remainder is taken, that is 11. So we get that T of 35, it's equal to T of 35 becomes T11. T11 is the actual number, and we can also verify that T5 star T7 equal to this way. We can then directly verify that T5 star T7, what is the answer then that we are going to get when we operate these two numbers. Then you can see that we get the answer. See, this is here the step behaves exactly like that of permutation operations. The permutation composition, Now you know that we have discussed the permutation composition operation, and in that way it works and gives us the answer T11. Similarly, we can verify all other operations between by considering any two elements arbitrarily, and we can find the answer. And so the second group, U12, see the second group, U12 bar. U12 bar acts as a permutation group. And you know, the Cayley table for both groups are given below. As given below, you can write the Cayley table U12, see 15711, 15711 along in this column. So answer answer obtained after the operation is also given here. And U12 bar, see U12 bar is equal to T1, T5, T7, T11, and here T1, T5, T7, T11, and the table contains the answers or the results of the operations when we, for example, when T5 is operated with the T5, and then we get T1 as the identity element of U12 bar. That is the identity element of this group. So in the same way, we can find, you can verify all these elements, all these members, or all these these given values are obtained by operating the corresponding elements which are selected from the column and row in the title column and title column and title row. And that can be one element can be selected from this set, and that can be operated with the element in the title row. You can see, verify that the answer given or the answer given here is the correct answer. Is the obtained it is obtained as the result of the operation. Okay, that way we can verify. Okay, and that is the end of the this further discussion that helps us to understand the Cayleys theorem. Thank you.